Chapter 4 is on exponential and logarithmic functions. In 4.1, we're going to explore exponential functions first. So the definition of the exponential function, f, with base b is defined by f of x equals b to the x, or y equals b to the x, where b is a positive constant other than 1, and x is any real number. So the exponential function f of x equals 42.2 times 1.56 to the x models the average amount spent, f of x, in dollars at a shopping mall after x hours. What is the average amount spent to the nearest dollar after 4 hours? So in this case, we have that x is equal to 4. So we want to find f of 4. Well, that's 42.2 times 1.56 raised to the 4th power. So we want to do order of operations first. So we need to find 1.56 to the 4th power. So 42.2 times 5.922 40896. Now we just want to go ahead and multiply this by 42.2. And so we end up with 249.92566. And we're going to round to the nearest dollar. So this is about 250. So to graph exponential functions, we want to go ahead and pick some x values and plug them in and find the corresponding y values. So we're going to make an xy chart. And so we're going to pick values. I'm going to go from -3 to +3. So when x is -3, we have f of -3, which is 2 to the -3. And we know with our exponent rules that this is really 1 over 2 to the +3, or we get 1/8. So we have the point -3, 1/8. Let's plug in -2. So f of -2 is 2 to the -2. But again, we don't like negative power, so we're going to flip it to the bottom, and we end up getting 1/4. So -2 and 1/4. Let's plug in -1. F of -1, that's 2 to the -1, or 1 over 2 to the first. So we get 1/2. F of 0 is 2 to the 0, and anything to the 0 power is 1. So we have the point 0, 1. F of 1 gives me 2 to the first, which is 2. F of 2 is going to give me 2 squared, which is 4. And f of 3 will give me 2 cubed, which is 8. So we have more than enough points to plot our graph. So we have the point -3, 1/8. So that means it's super close to 0. We have -2 1/4. So a little bit higher up, but not much. We have -1 1/2. We have 0 1. We have 1 2. We have 2 4. And we have 3 8, which is somewhere up here. And this keeps extending in both directions. So my graph of f of x equals 2 to the x will look something like this. Let's go ahead and do the graph of f of x equals 1/2 to the x. Go ahead and pause the video and try it on your own. So for this one, we're going to set it up the exact same way. We're going to have an x, y table. And we're going to plug in x values and find the corresponding y values. So starting from -3, we have 1/2 raised to the -3, but that's like having 2 to the 3, which is 8. So we have the point -3 8. F of -2 is 1/2 to the -2, and that's like having 2 squared, which is 4. So we have the point -2 4. F of -1, or 1/2 to the -1, is like having 2 to the first power, which is 2. So we have the point -1 2. 0 is going to give me 1/2 to the 0, and anything to the 0 power is 1. So we get the point 0 1. F of 1 is 1/2 to the 1, or just 1/2. So we have the point 1 1/2. F of 2 is 1/2 to the 2nd, which is really 1/4. So we have 2 1/4. And 3, we have 1/2 to the 3rd power, which is 1/8. So we have 3 1/8. So we're going to go ahead and plot these points. We have -3 8, which is somewhere over here. We have -2 4. We have -1 2, 0 1, 1 1/2, 2 1/4, and 3 1/8. So some characteristics of exponential functions of the form f of x equals b to the x. The domain of f of x equals b to the x consists of all real numbers, so from -infinity to +infinity. The range of f of x equals b to the x consists of all positive real numbers, or from 0 to infinity. The graphs of all exponential functions of the form f of x equals b to the x pass through the point 0 1, because f of 0 is b to the 0, which is just 1, as long as b is not equal to 0. The y-intercept is 1, and there is no x-intercept because you keep getting closer to the x-axis, but you never touch it. If b is greater than 1, the graph goes up to the right and is an increasing function. The greater the value of b, the steeper the increase. If b is between 0 and 1, then the graph goes down to the right and is a decreasing function. The smaller the value of b, the steeper the decrease. F of x equals b to the x is a 1-to-1 and has an inverse that is a function. And the graph of f of x equals b to the x approaches but does not touch the x-axis. The x-axis, or y equals 0, is a horizontal asymptote. So you can see a general idea right below. So when b was between 0 and 1, we have a decreasing function, which is our red line. And then if b was greater than 1, we have an increasing function, which is the blue line. In both circumstances, they went through the point 0, 1, and they both get closer and closer to the horizontal asymptote at y equals 0. So now we're going to talk about transformations of exponential functions. So these rules are very similar to the ones we've talked about before, except now we're just working with an exponential function as the main graph. So if I have b to the x plus c, that means we move up c units, and if it's b to the x minus c, we move down c units. If I have b to the x plus c, we move left c units, and if it's b to the x minus c, then we move right c units. Negative b to the x means we reflect the graph about the x-axis, and b to the negative x reflects about the y-axis. And c times b to the x, if c is greater than 1, then we vertically stretch it, and if c is between 0 and 1, then we vertically shrink it. And b to the c times x, if c is greater than 1, we horizontally shrink it, and if c is between 0 and 1, we horizontally stretch it. So we're going to use the graph of f of x equals 3 to the x to obtain the graph of g of x equals 3 to the x plus 1. So first thing we need to do is plot the original graph. So we're going to make an x, y table so that we can plot this one. So this will be the exact same method that we did in the first two examples. So I'm just going to put these in real quick. So 3 to the negative 3 is going to give me 1 over 27. Negative 2 is going to give me 1/9. Negative 1 is going to give me 1/3. 0 is going to give me 1. 1 is going to give me 3. 2 is going to give me 9. And 3 is going to give me 27. So let's go ahead and plot the original first. So I'm going to start from negative 1 and go up to 1 since the other one have pretty big y values. So negative 1 1/3, 0 1, 1 3. You could get really particular. but it's going to be something along these lines. So this is the original graph. We want to use transformations to find the new graph, or g of x. So our transformations we will be moving left 1 unit. So if I'm looking at the point, let's go with an easy one like 0, 1. It's now going to be moved to negative 1, 1. If I look at the point 1, 3, it's now going to be moved to 0, 3. And so from these 2 points, you should get an idea of what your graph's going to look like. So I have the point negative 1, 1, and I have the point 0, 3. So we have something that looks like this. Go ahead and pause the video and try example number 5 on your own. So for the original graph, we already found this table above, so I'm just going to copy and paste it down for example number 5. So our transformations you're going to move down 3 units. So let's go ahead and plot the original first. And then we're going to use our points to find our new one. So let's use the point 0, 1. If I move down 3 units, we're now going to be at the point negative 3, 1. I'm sorry, we're going to be at the point 0, negative 2. If I move the point 1, 2 down 3 units, we're going to be at 1, negative 1. So let's go ahead and plot this. So now that my graph has moved down 3 units, my horizontal asymptote has also moved down 3 units. So since it started at y equals 0, we're going to have a new one that's moved down 3 units. So our new horizontal asymptote is at y equals negative 3. So the natural base e, the irrational number, is approximately 2.72, and we call this the natural base. The function f of x, which is equal to e to the x, is called the natural exponential function. So the exponential function f of x equals 1145e raised to the 0.0325x models the gray wolf population of the Western Great Lakes. F of x years after 1978. According to the model, what was the gray wolf population rounded to the nearest whole number of the Western Great Lakes in 2014? So because x is the number of years after 1978, we're going to be looking for 2014 minus 1978, or x is equal to 36. So f of 36 is equal to 1145 e to the 0.0325 times 36. And so let's go ahead and simplify the exponent first. We have f of 36, which is equal to 1145 e to the 1.17. And on your calculator, your TI-83 or TI-84, to get the E button, you go ahead and you click the second button and then ln. And that will give you E raised to something. So let's go ahead and just calculate this whole thing out. And so f of 36 rounded to the nearest whole number is approximately 3,689. And so compound interest is interest computed on your original investment as well as any accumulated interest. So the formulas for compound interest: after T years, the balance A in an account with principal P and annual interest rate R in decimal form is given by the following formulas. For n compounding periods per year, we get A equals P times 1 plus R over n to the nt. And for continuous compounding, we get A equals P E raised to the RT. So you decide to invest $8,000 for 6 years, and you have a choice between two accounts. The first pays 7% per year, compounded monthly. The second pays 6.85% per year, compounded continuously. Which is the better investment? So for the first part, what's in pink, it pays 7% per year and is compounded monthly. And in the second one, or the purple, the second pays 6.85% per year, compounded continuously. So we're going to use both sets of formulas. So in the first one, our P is the amount we're investing, which is $8,000. Our rate is 7%, but we want to write this in decimal form, so 0.07. My N is how many times it's being compounded. So since it's monthly, that means it's being compounded 12 times a year. And my T is the time in years, so 6 years. So we just want to plug into the first formula given. We have A equals 8,000 times 1 plus 0.07 divided by 12 raised to the 12 times 6. Then we just want to simplify. So So A equals 8,000. We have 1 plus 0.07 divided by 12. All raised to the 12 times 6, which is 72. So this is pretty much calculator work. So typing it into your calculator, you get that A is approximately $12,160.84. For the second investment option, we're going to use the second formula because it's being compounded continuously. So the P is still 8,000. My rate is 6.85%, but in decimal form, that's 0.0685. And my time is still 6 years. So A equals 8,000 e to the 0.0685 times 6. So we have A equals 8,000 e to the 0.411, or A is approximately $12,066.60. So the first investment is slightly more than the second one, so the first one is the better investment.